talk about code analysis in an Agile world. I'll hand you over to Anna Jayne. This is a half an hour session, so it'll finish around 2 o'clock, ready for the next session in here. Okay, thank you.
Thank you, and welcome. I wanted to say I didn't expect it to be difficult. This is fabulous. I'm glad you're all interested in the subject of software code. For anyone who doesn't know me, I'm Anna. I'm the founder of Riverblade. We've got a stall out there. I'm not going to talk too much about that. This talk is really gentle. Right. If you want to ask anything, please don't feel you need to wait to the end. I've made this talk fairly short anyway. There's not that many slides, but just if you want to ask anything, just stick your hand up and ask me there. Right. Hands up. Who knows what a static analysis tool is? Okay. Not many. All right. There are really only 2 types of code analysis tools. There's static tools and dynamic analysis tools. What a static analysis tool does is read your code. It's a program that reads your code and it identifies things that could be wrong code smells, uninitialized variables, potential memory. Basically, simple, small things that can have big consequences. Most of them don't. But every so often, you will find a real howler, and ideally, the tool will find it quicker than you do. I saw, a few years ago, I was working for a company, and we ran an analysis tool over their production code base, and it spotted somebody had written a really long function, and they declared the same variable twice inside a function. Same name, same purpose. A human being reading that piece of code would assume that you get all the way to the end, and the value is the most recent one that you have. It's not, it's one from the outer scope. Now that particular change was the behavioral change in a production code base that was deployed on oil platforms, cable laying vessels. These are environments where downtime could cost you $200,000 a day. You know, it's serious stuff. And the code base, the analysis tool spotted it. We went to our testers, we said, we think, we're not sure, we haven't run this yet, but our tools are telling us that if you do this, this, and this, and then press that button, this would happen. And it went white. So I count that as a win. You know, it's a really subtle thing, but a machine inspection, a third-party analysis tool, did that job for us, and it told us what was going wrong. You can apply analysis tools to pretty much any language. In the C++ world, which is where I'm from, you've got PC-Link, you've got FlexiLink, you've got the big guys like Parasol, Coverity, there are loads of them. In Java, you've got PMD, Findbugs, Checkstyle, there's loads of them there. Even in the dynamic language world, Python, there's Pyland, in Ruby, there are a handful that I just read about, I can't remember the names. So it doesn't matter what language you're in, the chances are there is going to be some sort of analysis tool that can help you write better code. What I'm interested in doing is exploring how you can do that more effectively. So, if you go into a traditional waterfall type team, there's a very common set of use cases which have an impact on the way that the tools, any sort of tool is used within our industry. And if you look at, when you go from that into an agile environment, you have a whole variety of tools at your disposal. You've got performance tools, unit test tools, continuous integration tools, really important. Coverage tools, also important. They're all important. Analysis tools are just one of those. So what I'm looking for is to look at the ways that analysis tools in particular are used traditionally, and why that doesn't quite work in an agile environment. What I'm looking to do is try to work out how we can do things better in an agile environment. Okay? So catching things before they become a problem. I don't want to know about it when it's too late to fix it. Zero cost, or very, very low cost. I want to know when it's. I want to know about how to fix it when it's really cheap. In a traditional environment, what tends to happen is that analysis tools put onto a build server. So you've got a centralized analysis, and often it's only going to be run once a week or overnight. And the main reason for that is it just takes too long. I had a company several years ago that I was working with, and they had a code analysis run that took 4.5 hours. They had to fit it in around their nightly build. They didn't have a CI set. This is very much a pre-agile environment. A team of 21, I think. And so they ran it once a week, a weekend, because their build took too long as well. And then they completely ignored the results. And they wondered why their software quality was going down and their defect number was going up. You know, it's not the way to do things. The only thing that putting code analysis tools on your build server gives you is reports. And they're only as good as how up to date they are. So they can give you stuff to give to management to present, give managers a nice, warm, fuzzy feeling that they're actually measuring quality, but it doesn't mean fixing it, making it better. What we want to be doing is fixing it, or even better, fixing it before it becomes a problem. Agile software development values rapid development and continuous integration. So by the time the analysis results in the traditional build server environment are available, they're out of date. Or sometimes badly out of date. If you've got a piece of code, which is a 2 million line project, and it's generating 500,000 analysis issues every week, are you going to look at that data? I suspect the answer is no. What you're really interested in is, has it gone up? Has gone down? Where's it changed? Where are the hotspots in the code? And even better, can we stop it going up in the first place? I want to fix those new issues. I know we've got grot in this old cruddy code base that we've inherited from another company or from a previous team of developers. But what I'm interested in doing is making sure it doesn't get any worse, stopping the rot, and then triaging and fixing the stuff that's already in there that we know about. Okay? So a key part of the problem is the speed of the analysis. Now we can improve that a bit by fixing the most obvious thing, and that's that normally they are tending to reanalyze the whole of the code base every time you run it. If you've got 2 million lines of code, and especially if it's C++ code, where you've got header files, parsing all of that, analyzing it is a really time-intensive, CPU-intensive process. You really don't want to do that too often, not when you don't have to. So all you need to do is analyze, is keep a full set of analysis results from the previous run, look at what's changed, reanalyze just the stuff that's changed. And if that still takes too long, the obvious thing you can also do is make use of multi-core processors. Most analysis tools run on a single CPU. There's the only one I know of that runs on multiple cores simultaneously is CTP check. So if you've got 8 files and you want to analyze them in a traditional build server environment, then it's going to analyze them one after another. Do not all 8 at the same time. Don't muck about. You can even throw it onto other machines in your environment. Has anybody ever been in one of those environments where all the dev team leave their machines on all night because nobody wants to shut it down? And they get told off for it, but they still do it. Right, well, if your analysis is taking too long, no matter what else you do, use all the cores on the build server, great. Co-op those machines that are left around the office on overnight. I can do a lot more with 50 cores or 56 cores than I can with 4. that means the analysis gets faster and you get more results and they're more up to date, which is really important. One of the, and that still is saying, well, I could have changed absolutely loads of stuff. It could still take forever to reanalyze this code base. It's still not quick enough to run in a continuous server environment, continuous integration environment. So what you do is you say, well, I want to keep the analysis results from last time. I'm going to do an incremental analysis, focusing on files I've got no analysis results for first, which are the new files. Then I'm going to go back over the files which have changed, so they've got stale analysis results. So you prioritize which order you do the analysis. Run the whole thing in parallel, and then I'm going to set a time limit on it and say, on the CI server, do this after every check-in, and don't take longer than 5 minutes. That means you get a very, very rapid turnover of analysis results. You're getting immediate feedback, and you're finding out what is happening in your code base as the commits are actually happening. We do this on our own code base, in our own CI server, which is cruisecontrol.net. And it's great, I have analysis results pretty much up to date all the time. We can immediately see when if they're getting worse. In practice, we don't tend to look at them that often, which kind of leads me to something else which I'll get onto in a minute, but just using the grid analysis, go back a point. Our code base was originally, the last time we measured it, it was 100. We did a benchmark on it. It took 4.5 hours to analyze it on one of our dev machines from scratch. That full analysis we got down to 12 units, just using parallelization. We now need a time limit to check-in, so we turned off the grid analysis bit because we don't need it, it's fast enough. We've still got it if we do need it. Generally we don't. And that's great, so we've got our CI server running. We've got our code analysis results available for whatever analysis tools we care about for the code base we're analyzing. And we've got them available to us after every check-in. Fabulous. What could be better? The problem is that your analysis results are still out of date. They tell you what the code base is that's checked in. What they don't tell you is what the devs are doing on their own development environments, on their own machines, right now. The code they're about to check in is going to change those results. Then you'll have a new set, and then you'll have new problems. So really what you need to do is to take that analysis and put it into the developer's hands as well. You need the centralized reporting because that tells you what the code base is doing as a whole. You could be working in your environment and you're doing great, and you're really happy with the quality of your code, and then someone checks something in, you get the code out, you analyze the bit that they've done, and it's rubbish. You kind of don't want that to happen. You want them to learn the same things that you have, and you want them to teach you stuff as well. So, if you're running code analysis software at all, any sort of analysis tool, it doesn't matter for what language, and you're putting it on the build server or into an environment like Sonar or Jenkins, great. But you need to give it to the devs as well. This particular screenshot is from our software, but I hope the intent is fairly straight. It's fairly obvious. We've got a piece of code there, and as this particular pointer hasn't been initialized, potentially that's a crashing waiting. The chances are perfectly benign, but it could be a real one. If the dev has a chance to see that before they commit the code, assuming they've just written it, then they can fix that. They can put a log check-in or something to find out if that's a real condition. They can test the variable if they need to. Otherwise, you're only going to find it once they've checked it in, they've finished the task. Once they've finished the task, they're on to the next one. And you will find, no matter how good your devs are, if you go back to them and say, I found a bug in something you did 2 days ago, can you please drop what you're doing and fix it sometime later in the sprint? They are not going to like you. So the idea is to find these things before they creep in, before they contribute to architectural decay, before your code becomes less maintainable, less stable. It's just part of the portfolio. It's no different to analyzing the code, to running, say, metrics on the code or code coverage. There are things you want to measure, and you want them to be getting better over time, not worse. In our software, we don't just run analysis tools in our software, we run metrics tools as well. And one of the things we measure is a metric called average cyclomatic complexity. Now, the cyclomatic complexity of a piece of code, a function, is a measure of the number of paths through that function. So it's a measure of the testability of the function. And if you average that over the whole code base, then you can get a pretty good idea as to how testable the code is as a whole. It doesn't tell you anything about decoupling or any of the other metrics that get in the way of testability. It won't tell you if something used a singleton or any of the other code smells of that type. But what it will tell you is the code as a whole is potentially more testable or less testable over time. So we measure that as well. And these things go hand in hand. If you're not measuring code metrics, look into it seriously. There are free tools to do it. It's well worth doing. If you're not analyzing your code, look into it. There are also free tools to do it. You don't have to buy anything to do this. We'd like it if you would, but I'm not going to insist on it. There is a real human problem here as well. We are all fallible, opinionated creatures. We're prone to, no matter how good we are, we're prone to cutting corners and doing it the easy way. And every person, every developer has got a different bunch of that mix. So if you're a real rock star, you never cut corners. Your code's always perfect, right? No. Anybody heard of the 80% problem? 5 years ago, Ben Collins Sussman observed that there are really only 2 types of programs. The 20% folks, leaders, rock stars, or whatever you want to call them, and the 80% folks, who are the vocational programs. What he said was quite interesting. There are 2 classes of programs in the world of software development. I'm going to call them the 20% and the 80%. The 20% folks are what many would call alpha programs. The leaders, trailblazers, trendsetters, the kind of folks, places like Google and Concrete Software are obsessed with hiring. The 80% folks make up the bulk of the software industry. They're not stupid, they're just vocational. They went to school, learned just enough of whatever language they like, then got a job writing internal apps for banks, governments, travel firms, law firms, etc. I've met an awful lot of 80% programs in my career. I've met quite a lot of 20% programs in my career. These guys outnumber, but not at conferences. Conference folks are up here usually. And that's not just self-congratulation. If you're coming to a conference like this, it means you're interested in learning. You probably read blogs. You're talking to other devs outside your organization. Most of the industry is not doing that. And this has a very specific impact when it comes to any soft quality tool. What it means is, on average, only 1 in 5 of a typical development team will care about improving stuff. 4 out of 5 folks won't want to change anything. They won't necessarily want to learn. You have to lead them. You have to educate them. You have to mentor them. We have some anecdotal evidence of this ourselves. We did some work with a tech company in the Netherlands a few years ago, and the lead developers were rolling out analysis tools across their teams. And they were really loving what they saw. They were loving the sort of improvements it allowed them to make to their software. And it was great. And after a year, they gave up. And they said, the reason we've given up is that only 21% of our developers will use it. So there's a real human problem here. The challenge we have is to work out what the human solutions are to that problem. And they have to, because it's not a technical problem, it's a human problem, we have to look at it in human terms, in terms of education, in terms of mentoring. What can we do in leading our teams to help people to learn to do things better? A lot of it is leading by example. If people see that doing X instead of Y will make their job easier, they'll generally do it. But you might have to cajole them to get them to start to try X in the first place. What you in analysis terms, or in terms of code analysis, there's a particular scenario that I call the Devon corner. So you've got like a 5-man team, and there's one person in the corner who's fixing all the quality problems in everybody else's code. It doesn't matter whether they're using analysis tools or anything. What you really want to get in is everybody fixing quality problems. I want everybody to be able to sniff scoping errors and bad casts and potential exceptions and crashes. And you've got to work on educating your teams. And that applies to all of us. The guy next to you is, you know, you can learn something from him, you can learn something from you. So the chances are that unless the content of your team is really atypical, you're going to have some of these 80% folks on it. If you have, I suspect they're probably not here. Okay, interesting stuff. I'm not expecting you to follow this in detail. This is a script. This is the result of a shell script run on a Linux machine using Mercurial as a back-end database. The idea here, this is using CPP check. You can find it there if you follow it through. There's a CPP check script there. And what it does is the developer's about to check in a file. The script, as he's checking it, the script runs that, analyzes that file, and also gets out the previous version of the file, analyzes that, then diffs the results. And if the warning count has gone up, it tells him your code is worse. Do you want to fix it? So you've immediately put a roadblock in that smooth path to checking in poor code. It could be something really simple. In this case, it's an unreferenced variable. Something that has probably no dangerous side effects, but you don't want it. So the whole point of where I'm going is to say, let's take these roadblocks and remove them. This is one way of removing a roadblock. Finally, Agile warning policies. The warning policy you apply to your code is really important. If you analyze a code base that's never seen analysis, has never been analyzed before, the chances are you're going to get flooded with results. That's useful data, but it doesn't help you fix the things that it's identifying. You need to set up a warning policy accordingly. So what I typically advise new customers to do when they're doing this for the first time, analyze it with all the knobs turned on. Dump the data into a spreadsheet, and turn everything off except the stuff that you care about. But the important thing is that once you've fixed all that stuff, start turning more stuff on. Keep at it. Plan refactoring into every sprint. Review your warning policy regularly during every sprint. You know, you get to the end of one sprint, you do a retrospective, review your warning policy, look at the analysis results. What else do you care about? Has it got better or worse? Take action. That way, your code will get better. Finally, hopefully I'm on time. I thought I'd come up with some principles just to encapsulate the sort of things that I see, that I find have been important in not only improving the quality of our code, but working with our customers to see how we can help them to improve the quality of their code. So I came up with this, some principles. Interactive and centralized analysis. rather than just centralized analysis. In other words, give it to the devs, not just the builders, get everybody doing it, mentor them, train them. Incremental analysis rather than reanalyzing everything from scratch every time. No point in spending hours reanalyzing stuff you did yesterday if it doesn't change. Make it easy. Use all your calls, not just one. Self-explanatory, make it quick. When every time files are committed, rather than frequently, and following on from the previous slide, we want to run before and after commit. So before you commit the code on the developer system, after you commit the code on the CR system. And obviously review and evolve warning policies continuously during the sprint. Okay? And that's it. Thank you. Any questions? Yes?
How do you feel about breaking the building based on?
It's an interesting question. We had a customer come to us a little while ago and said, we want to set conditional warning codes in the software. So we said, okay, what do you need? And when it came down to this, we said, well, you can do it, but you've got to choose the conditions carefully, and it's very much context sensitive, and you need to review it regularly. So you can say, okay, I'm going to break the chain, I'm going to break the build if there's a warning. It's probably not the best thing to do, but what you might want to do is set a threshold that you think you'll never reach. Say, okay, I want to break the build if there's more than 50 warnings. Because then you have some warning, if you're checking the analysis, the results of the continuous integration build on a regular basis, which you should be, you have some warning that there's a problem approaching before it actually arrives. Okay? But again, it's something you need to review. It's like the warning policy. If the warning policy, if you're reviewing the warning policy, you also need to review what you do with the warning policy and how you translate that into failure conditions. Any more questions?